So we are starting now, guys. Welcome to lecture 4, Unleashing the Secrets of Smart Contract Programming. And in this lecture, we'll work on how complex smart contract code is written and what are the current happenings in Web3 so we guys can catch up. So before moving on into lecture 4, let's have a quick recap of lecture 3. And before that, do you guys have any doubts for us or any questions for us? Any questions? How many of you guys went through the pre-reading playlist or pre-reading blog series? Okay. Okay. Decent. So now let's go on a quick recap. In lecture 3, we discussed about DeFi versus CeFi, what DeFi is, decentralized finance and centralized finance, and how they both differ fundamentally, and how liquidity problems should be solved on a blockchain, and how lending pools solve it on a blockchain, and what are lending pools. We also saw what is liquidation in a lending pool and why liquidation is necessary. We covered flash loans. We learned that flash loans are a type of loan attack where a user borrows a huge amount, makes the transaction, and in the same transaction returns the borrowed value plus the interest amount back to the contract where he took the loan. So this is flash loan. And collateral swapping. Collateral swapping is you collateralize something. Let's say in a simple term, if you are having your, if you want to take a home loan, you submit your house documents and you take out the amount from the bank, right? So in collateral swapping, what we do is people will give either their ETH, ETH, DAI, USDC, USDT, or some other cryptocurrency tokens, and they get other type of cryptocurrency tokens in exchange for that. And we saw about automated market makers. And what are automated market makers? I mean, in stock exchanges, how many of you guys know stock exchanges? Maybe whoever attended lecture 3 should have a good idea on it. So how stock exchanges work? If anyone wants to sell and at the immediate time, if anyone wants to buy, both the orders are matched. But how can we exchange between tokens on a blockchain? So that issue is solved using automated market makers, where everything happens automatically. If one wants to sell, he can sell it. And slippage. Slippage is a parameter in automated market makers. It's like if we are executing a transaction, how much difference comes for the previous price of the particular asset and the current price we are getting the asset for. And stable coins. So what are stable coins? We learned if any sort of asset we are possessing, we can't bear if its value suddenly dips down. Maybe we can tolerate if its value goes high suddenly, but we can't tolerate if its value goes down all of a sudden, right? So cryptocurrencies are highly volatile. We don't want our currency, whatever we are investing in or possessing, should lose all of its value. So there comes the concept of stable coins. And most of the stable coins are USD pegged. And later there comes oracles. There came a very nice question which we asked in lecture 3. How come blockchains get real world data, or how can blockchains communicate with the outside world, right? And what does Oracle solve? Oracle solve the same problem. So any doubts on this? Now,
I'll take it.
yeah.
Okay, guys. So first of all, welcome to the last and final lecture of BC106. I am Basil. Here's Manoj. Just to get a basic idea of the room, for how many of you is this the first lecture? 1%, right? बाकी लोगों ने at least एक lecture किया है, मतलब आए हो यहाँ पे at least. Or if you have gone through the study material, whatever. And how many of you have followed up on last lecture and like tried to do something on your own, as in went through the slides, read through it at least once, or मतलब basic sort of revise कर लिया एक बार, right? What was done in the last. ठीक है, if अगर नहीं भी है तो कोई बात नहीं, I'll try to follow from the beginning. So in this particular lecture, what we felt was we have started from giving you a basic overview of what all there is in the Web3 space. So sort of demystifying the landscape of Web3. Then we went to then we went to sort of learning Solidity, right? The basic smart contract writing language. And then in the third lecture, we focused on DeFi, which was decentralized finance. And we learned a lot of concepts which were at the intersection of uh, computer science and economics, right? So things like flash loan, market makers, these things actually we borrow from economics and finance. So in today's lecture, what we felt is we'll try to marry coding and finance together. In what we'll do is we'll actually try to build Uniswap. So we had actually had a very extended discussion on Uniswap isse pehle, if you remember. So we'll look at that and we'll try to build it in Solidity on our own. It will be obviously it will be a toy example. Currently, Uniswap is on version 3, which is more advanced and there are like more concepts. But for for the introduction for simplicity, we'll only be working on we'll try to build more version 1, which is just the basic token exchange platform. And then Manoj will take you through current innovation so that you guys have a sort of a roadmap of where to head next if you're interested enough. So moving on, we'll start with building our own Uniswap. So obviously, before we start even trying to build something on in Uniswap, two things we'll have to assume. First is you understand what Uniswap is. It is a liquidity provider for two tokens where the demand and supply are determined is perpetual, determined by algorithmically determined prices for the two tokens. So let's break it down. Basically, what I'm saying is, if you go today and you want to, let's say, buy, give me a token, let's say yen. Okay, you want to exchange yen for INR. Okay, so what you go is you go to exchange and you will buy your exchange your yen for INR whatever price the market sets it at, right? In case of something like a blockchain token, the trouble is that there is no liquidity, which means that if you want to exchange your token for let's say ETH, the problem is there's not another person who can give you that token. So how do you fulfill your trade? And if there's no trade happening, then I mean it's a vicious cycle. You cannot use that token for anything, right? So that is what Uniswap solves. It basically says that there is no need for another person to have a market. And how does it do that? It basically stores two reserves of both tokens, whichever it is trying to trade. And for both the token, it will use a formula to determine the price of one with respect to the other. So just to understand this in a basic example, let's say I have a token. Basically, let's say I have two things. I have one token which is ETH, and I have another token. Let's just call it TKN. TKN. I want to create a pool for them. So basically, if I have this, I have this. In the smart contract that is storing, that is the my marketplace, that is the smart contract. I deposit 200 units of ETH and 1,000 units of TKN. Right. So now if I ask you how much is one ETH worth in terms of TKN, what will you say? So you'll basically, I mean, since this is more, I mean, this will be, I think, more basically, you can put it as this. So P of ETH is basically, no, why do you say one? Basically, it will be the reserve of quantity. So ETH, one TKN. Right, because that is more abundant, so you'll have this. So basically what we're saying is we are using the ratio of the reserve quantities as a way to determine a particular token's worth. Ratio of the reserve quantities of the tokens. Does that make sense? This does make sense, right? Okay. We'll review this idea further later on. Okay, but so that is basically what we're trying to do here. Another way to determine the price or to provide liquidity would be to provide liquidity yourself, which is you yourself as a developer buy some amount of ETH, some amount of the token, and you deposit in the contract. I mean, for you, let's say you are starting a new exchange for your own token. Obviously, you can just say that the token reserve is equal to 1,000 or 1 lakh because you're just creating it out of nowhere. But for the ETH, you have to deposit it, right? So that process, either you can do it, but the problem is you cannot do it if the order, the liquidity is large enough. So if you expect that it will be like a global thing, then you cannot provide that much of ETH because the तुम्हारे value नहीं है. Okay. So that is why we'll have to rely on the fact that the liquidity is not provided by the developer, but it's provided by the people themselves. We will talk about that. So we'll look at that later. Coming to the more important point of market makers. So I told you about this idea that there has to be some mathematical formula which determines the price. Okay. Now this has been like talked about in the previous lecture, so we'll just review it here. Basically, what we're saying is, let's say you have two tokens X and Y. So you say that the X and Y are not tokens. This is the reserve, the quantity of token of some kind, and this is the token of another kind. Unka product is a constant. Okay, in the reserve, in your contract, which means if you increase, let's say if at some particular time, some person is depositing a lot of X type token in the contract, then the Y token should decrease, which is like they'll try to take away that much amount of Y. Okay, nobody will just deposit tokens for free. It's not obvious. So there'll be like an exchange, there'll be like an interplay between them, and the product will be constant. This is like at the heart of Uniswap version 1. We'll use this and we'll use this to determine the price of both the tokens. We'll get into that later. Sorry. So I think so we'll and second thing that we'll sort of review is I don't know how much of solidity we are aware, because coming 10-15 slides will be like a lot of code. So we'll go through each line one by one and we'll try to figure out what each line is doing. I would expect you to at least be aware of what interfaces are in Solidity and at least what ERC20 contracts are. If you are not aware, it's totally fine. बता देता हूँ एक बार. So what are interfaces? I'll just give you a very brief conceptual understanding what interfaces are. In programming, what you do is, let's say you have your contract. Okay, let's call this thing C1. This is your contract. You have written this. And let's say there is some other person who has written some contract, M1. Now, the thing is, for your contract to work, you want to communicate with M1 for some utility. Okay, maybe you want to determine the price of something, or maybe you want to use it for trying to figure out if there's a user on the contract, etc. Okay, now in a very short description, an interface is basically a programming construct which gives you a way to communicate with some other contract which is written by somebody else in a logical fashion. Okay, this is something like if you guys are aware about network protocols or something, what it basically does is there is like a pre-established rule between both of the parties of what one will be sending and what one will be receiving. And a very easy way of doing this is basically via function signatures. So let's say if my contract there's some function called get name or something. Okay. What I'll do is I'll try to create an interface of this function here, get name, with whatever parameters it wants, whatever it returns. Right. This will be my interface, and whenever I want to call this, so this will reside at some address, OX something something. This will be M1's address. What I'll do is whenever I create my interface, I write something like this. This is the a very dummy my interface equal to, I'll call this thing, and I'll pass the address of the contract. So what is sort of creating? I mean, are you guys colleagues okay? Have you guys ever instantiated an object? Are you guys freshers, no? Okay. Okay. So let's just say, I mean, forget about objects. What we're basically saying is, पीछे वाला क्या है ना? हाँ, class. ठीक है, first year से यार, ठीक है. You guys are doing call 100 in which language? C में तो होते ही नहीं है. हाँ, ठीक है, never mind. ठीक है, so I mean at least ये समझ में आया ना, this conceptual understanding आ गया ना, ठीक है. So we'll take this forward with interfaces. And why are interfaces important? Simple बात है, when you are trying to build a very complex application, your complex contract, you will want to interact with, preferably you'll want to interact with a lot of other contracts. तो तुम उसको खुद से नहीं लिखोगे, right? Obvious, you'll try to use building blocks. This is basic programming, what do you call, philosophy. So you'll try to use recycle other people's use. So that is why interfaces are important. Secondly, ERC20. ERC20 is a standard. ठीक है. ERC पता क्या होता है? Try to look up ERC. ERC is like full form नहीं पता, but these are basically proposals for improving Ethereum. ठीक है. So basically what happens is there is the first version of Ethereum. ठीक है. And उस पे कुछ core team काम करती होती है. Then there's also community which are who are using the technology, right, using Ethereum. So they'll have an idea of what can be improved. Then these people sit together and they write what can be improved in the form of ERCs. And the number that you see, 20 or non-fungible, it's I think 7. नहीं यार, मैं तो कोर्स का कोड 741 is, yeah, 721 is non-fungible tokens. So what we're basically saying is that there is a directory of these serial numbered ERCs, okay, where these people basically write different things and which can be improved on the protocol. ERC20 is a description for something called a fungible token. Okay, it basically says how a token can be sent, transferred, or basic things can be done on it, like, you know, creating it or destroying it or transferring it from one account to another. So these basic things are determined, not determined, sort of laid out. The rule is laid out कि ये कैसे होगा. ठीक है, we'll get into that also. So if you're not understanding, it's totally fine. Moving on, let's get to our first piece of code here. So code trigger warning. ठीक है, बहुत code आने वाला है. So let's just start deciphering some of the stuff. So structure of the project. Let's say you, अब जरा सोचो, ठीक है. What we're trying to do here is we're trying to make a token. We're trying to make a Uni Swap ourselves. मतलब वहाँ पे कोई dummy token होगा, and then there will be ETH, उसका एक liquidity pool बनाना है. So what we have is we need three things. First, एक factory चाहिए. बताता हूँ क्या होता है. Exchange चाहिए, and we need a token. Token is bold क्योंकि ये token का code है, ठीक है. So the idea is you will have a token contract somewhere. This is the ERC20, okay, which means इस contract में you will have all the description of how tokens are manipulated, okay, how they are created, burnt, etc., transferred from one account to another or from another account to my account. Okay, ये description यहाँ पे होगा. Now what happens is your main contract would actually create an interface and communicate for basic applications. Okay, and your main contract, like basically the blog or the set of documents that we have used for this tutorial, they call it Z Uni Swap. So we'll just call it Zuni for this. Okay, so Zuni is communicating with the token, and the main अपना business logic of determining prices, determining reserves, and adding liquidity will reside on this contract. Okay. There's also one hidden advantage of this. When you sort of decouple your projects in different contracts and you actually delegate this to something like Open Zeppelin contract / ERC20. So Open Zeppelin is actually a collection of community created and community maintained smart contracts, जिसमें bugs काफी कम है. So if you try to write your own ERC20, you can write it. There is a specification document which tells you किसमें क्या क्या होने चाहिए, and you can write it in Solidity yourself. But it is preferred to use this because इसमें if there is a bug, मतलब तुम्हारे वाले document, मतलब तुम्हारे वाले contract में there might be a bug which will be lethal for the project. So it is generally recommended to use something which is tested by the community and used by the community at large. This is again common coding practice. Okay. So what we write here is we write contract token is ERC20. ERC20 is, we're basically saying that this particular contract, the token that we are creating, is actually ERC20, which means that it will inherit all the properties of ERC20. उसमें जो functions लिखे हैं, ठीक है. I mean, I can actually go to the website and pull up ERC20 का पूरा specification. You will see वहाँ पे there are stuff like mint. Okay. There is some function called burn. You should define it. Now, by saying that this contract is ERC20, is a programming, let's just call it a construct. Okay, it is. I'll not use that term, but basically it is saying that using that word is, you are saying that my contract will have all the functions of that contract, although I have not defined them myself. Okay, so that is basically what it is. And in the constructor is again, पता constructor क्या होता है? नहीं पता है, ठीक है. So let's see how we can explain constructors. ठीक है, रुको. So when you create this contract, when you create the token, you will need to have उस token में कुछ identity. ठीक है? That information you provide in the constructor when you establish the contract. When you deploy the contract on the chain, there is some blockchain somewhere. समझ रहे हो? You are writing your code on your platform, then you will use some software called Hardhat or Truffle, which will deploy it on the contract. So when you create that, at that time, it needs to have some identity, right? What information you provide in the constructor. I mean, now this is constructing something, right? Okay. That is अभी कितना समझ लो. In this particular case, we are providing string is a data type. Data type तो पता होगा, ठीक है? I mean, this is especially for the first people. So name of the token, symbol of the token, and U256. बता सकते क्या है? Unsigned integer 256. ठीक है. So that is what we are using for the initial supply. उसके बाद that is the construction का signature. We are expecting these things to be added. We call the constructor on the ERC20 contract. So this is something like, see, it is like my token ERC20. Okay. So this is some other person is doing it. He opens up in the folder. Since my token is inheriting, my token is going there. Okay. So I'll basically want to say कि पहले तुम यहाँ पे जा करके ERC20 को बना लो, and then you come back and then you do what I want to do. Does that make sense? Okay. Because I am sort of saying कि मैं ERC20 हूँ. So I first call the constructor on that contract, जिसको मैं inherit कर रहा हूँ. The word is inherit. Inherit again is understandable, right? You are trying to take over somebody, some other contract. Okay. So you call that, and then उसके बाद you will say that you mint that amount of. Okay. So wait. अब मुझे ये बताना पड़ेगा. What is MSG? Message. Message बोला ना? Good. It is actually message. ठीक है. So see, think about it this way. अब से तुमको ऐसे सोचना पड़ेगा. When your contract is deployed on the chain, how will a normal user interact with the contract? By creating a transaction. ठीक है, इतना तो पता होगा. Ethereum में you interact with the contract via a series of transactions. So when you send a contract, some transaction, that transaction is stored in an object called message. Okay? And this is the standard way of storing it. And the dot is like you're accessing some data from it. And the data that you want to specifically access is sender, which means the address that created that transaction. Okay? So if basically it says that if somebody creates this contract, okay, they will have to supply three things: name, the symbol, and initial supply. Then it will first go to the ERC20 contract. It will first create ERC20 expects two things: name and symbol. So something like you can name just some string like Uni Swap, something like this. So you supply this as name, you supply this as the symbol. Okay, and then after that, the mint symbol is actually creating and just bringing into existence initial supply of tokens, okay, which are sent to the sender. That's it. Okay, I hope it's not clear. Okay, that took some time. Now the second part. So this is just the bare bones. We are just setting up the project at this. Okay. So अभी हमारे पास क्या क्या है? We have the ERC20. We have our own contract. No wait, कुछ गलत है यहाँ पे. Wait. हाँ ठीक है. This is okay. So we have done these two things. ठीक है. Now we'll create the third thing, which is the exchange itself. I mean, this is the exchange. So this is the exchange. We have created this, which is the token. For the sake of simplicity in this diagram, ERC20 and token are सेम थिंग, ठीक है। उसको मैं यहाँ पे थोड़ा सा ब्रेक डाउन करके बता दिया कि सिंस इज इनहेरिटिंग इट विल एक्चुअली दिस, बट वी डोंट नीड टू केयर, फॉर अस इट इज दिस, इट इज लाइक एप्पल इज फ्रूट, ठीक है। अब एक्सचेंज पे आ गया, लेट्स टॉक अबाउट द एक्सचेंज। सो cool. So let's talk about the exchange. When you create the exchange, what information do you need? You need the address where the token is stored. So token is also a contract. Okay, your description of the token with my token, it is stored somewhere on the blockchain. Uske token address hoga. So when you create the exchange, you need to know where that is. And again, when you create the exchange in the constructor of the exchange, you supply the token. Iska data type dekho, it's an address. Address is the standard data type. It is some bit of hexadecimal numbers. Okay. One new thing that has been added here is a required statement. Okay. Requires are very important. I'll tell you why. Basically, requires are like checks. Okay. It requires says कि तुम्हारे पास एक statement है. If it turns out to be false, you will throw an error and you will stop the transaction. Okay. In this case, we are saying that token should not equal to what should not be equal to address 0. Now यहाँ पे क्या होगा? We are basically saying whatever token you supply should not be equal to this particular address. Okay. You know, addresses are stored as 0x. उसके बाद you store the hexadecimal. Okay. X is like the hexadecimal representation. So if it is a 0 address, you say invalid token address. Why? Because in Ethereum, the 0 address is sort of like the black hole. ठीक है, वहां पे whatever transactions you create, it will be destroyed. It is not meaningful. So you just ensuring कि तुम्हारा जो token तुम बना रहे हो for whatever exchange, it does not accidentally go to the 0. मतलब it does not get pointed to the 0 address. ठीक है? And then simply you assign your token जो तुमने supply किया into the variable token address, which is stored on the exchange. ठीक है? So in your exchange, you have one variable called token address, which keeps track of तुम्हारा token कहाँ पे exist करता है. Why is this important? Why do you want to keep track of where the token is? हाँ, because जैसे मैंने यहाँ पे बताया, when you need to communicate with someone, you need to know where they exist, right? I mean, obviously, when you need to call someone, you need to know their phone numbers. तो यहाँ पे basically same चीज है. So ये token कहीं पे exist करता है. When you want to initiate some sort of transfer of this token to somebody else, you need to know where that where this particular token is, and then you will use this token address then to open an interface, and then you will create your you will call that function. ठीक है? इतना समझ में आ गया? Cool. Now let's talk about the first and important part. Okay, my slides have been changed in layout. Okay, so so that dot represents ये सारी चीज जो हम लोगों ने कंस्ट्रक्टर वाला बना लिया. ठीक है, डॉट मतलब वो हो गया. Now we are focusing on this part of the code, which is a function. So solidity पहले किया है यहाँ पे किसी को प्रायर एक्सपोजर है थोड़ा सा भी, थोड़ा सा है. Can you understand that line? The
creating a function that add liquidity and this function में we input would be outside integer.
ठीक है.
Make that token amount.
ठीक है.
And this is the public function and others can also edit that. I mean, the other users on the blockchain
Can edit name, can call it.
call it.
ठीक है. And payable is
some payless transaction, gas transaction.
gas less.
Like, is that transaction payable or it is just like showing the balance or it is like in
fair. So close enough. It there are few इसको modifiers बोलते हैं. These are basically saying sort of like permission for the functions and their capabilities. ठीक है. So security measure है. It basically तुम्हारा solidity language के साथ ही आता है. It says कि different functions have different capabilities. ठीक है. So we'll use modifiers to tell them what they can what they are capable of. In this case, it's public. Option can be private, can be internal, can be external. Okay? Like these words can be used and they have different level of access. Okay? Payable basically means that this function can accept Ethereum. Okay? Which is like value. And that is important. And secondly, there is something called it's called pure. Okay? Pure means that particular function is not relying on any data on the chain, okay, to compute its, to do its job. मतलब वो read भी नहीं कर रहा अपने values. यहाँ पे इस particular function में can you tell me one value that we have stored on the chain? The token address. Okay, the token address is stored on the chain. But let's say I create some function which is calculating the square of some number, है ना? उसमें will not be needing any of the token address वाला चीज. तो उसको we can label as pure. Why is it important? Optimization के लिए, so that when you compile that contract, it will be more gas efficient. Just इतना समझ लो. ठीक है. So okay, coming back to this. So good job then. So we create this function for add liquidity. So obviously when you create a contract, you need to add value to it. As we have discussed, we need two things in the contract. First, the Ethereum. Ethereum matlab, that is by default always there in any contract. You can always have Ethereum there. And secondly, you need to create a token ka matlab amount. That is where you call the interface and then you transfer it into this one. I'm going to explain karta hu. Try to understand. So we are also recording. Hello. So first line is saying IERC20 token equal to IERC20 token address. This is where we are creating the interface to our ERC20 token. समझो उसको ध्यान से पहले. The I suffix नहीं prefix does what? I is मतलब एक क्या बोलते हैं इसको, एक convention है, एक standard है, where it says कि हम एक interface बना रहे हैं. ठीक है. In this case we are creating the interface to the ERC20. ठीक है. And it's called token. Variable चाहिए, बाद में address करेंगे उसको. And the token address, simple as that. Okay. So we create an interface with the token. Now, what we do is we transfer from, it's काफी readable वैसे, transfer from sender to this address, this much amount. Okay. So when you're creating liquidity, let's say you want to create liquidity, what you will do is you will have some amount in your wallet. When you create the transaction, you call this function. You write token amount 100 and then you have 100 of your token. How do you have 100 of your token? You just create it. Okay. That is what we're doing. Like we're providing liquidity. You just create it. You create it and then you transfer it to the contract. It's just a way of transferring it from your wallet to the contract. Now, look how simplified it is because we have used an interface. Otherwise, we'll have to define what transfer from does. In this case, we know what it will do. क्योंकि that is the interface that we have been provided. यहाँ पे हमें beneficiary का address देना है, यहाँ पे the benefactor and यहाँ पे the amount of benefit. Okay, so it's transferring from this to this way. Okay, and also we have this cute little function. It's get reserve. It basically यहाँ पे देखो the view is okay. So can somebody explain what the view does? Again, we have a bunch of modifiers here and also this kind of thing. So, कोई बता सकता है what the view modifier does? Manoj? Yeah. What is the purpose of the view modifier?
Actually, what happens with view is there is state of the blockchain, and view access the state of the blockchain. It reads the state, it makes its own computation, and it returns. That's it. It won't write anything to the state of the blockchain.
ठीक है. समझा? So, कुछ doubt है. Doubt? So we have like 3 levels, right? We have pure, view, or just nothing. मतलब तुम कुछ मत modify लिखो. ठीक है. Default is this. Pure में you are not even reading the data of the chain. ठीक है. Whatever you have stored. View में you read but you don't modify. And then there is like you can modify. And then payable comes something on the totally other side. Payable is like I can accept Ethereum as no, क्योंकि Ethereum में value है इसलिए इसको modify करना. ठीक है. Cool. And it returns an integer. ठीक है. To simple integer. This is basically saying कि इस contract में जितना भी value है वो मुझे बता दो. Does that make sense? ठीक है. It's basically saying यहाँ पे देखो यहाँ पे ये थोड़ा सा single line statement है, इसको double line में split कर सकते हो. When the first line you don't write this, you write this, okay, and then you return token dot balance of address this, okay. यहाँ पे this variable क्या करता है? This is referring to the contract that we are writing, right? The exchange contract. तो उसका address में से उसको balance of बता दो, इसका balance कितना. This is the reserve. This is, so get reserve to tell me what? It will tell me the quantity of the token in the contract, in the exchange. मतलब मेरे reserve में कितना token है. And let's say you want to know the amount of Ethereum in your contract. How do we know the amount of Ethereum in my contract?
It's not it's standard, not balance.
नहीं मतलब अपने this contract का.
The same contract, what we use balance, message dot sender, and we use to balance.
Message dot sender is a variable.
Yeah. Uska balance.
But message is like the transaction that is created by the some other user, right? Uska
In the same contract, we can write message dot sender balance. For that one. Balance of message dot sender.
हाँ वही ठीक है, we'll look into that. अभी इसको रहना, let's move forward. ठीक है.
Yeah.
हाँ
Yeah.
हाँ
One. Actually, we can call balance of any address on blockchain using address dot balance. So if we want to know balance of any smart contract, where we are executing, we can simply make this call message dot sender wrap with parentheses dot balance.
So you're basically saying something like this. This will tell you the quantity of Ethereum in the exchange. Okay. So I'll just go back to the slide so that you can relate. यहाँ पे we are doing creating the interface and trying to find out this particular contract में balance of the token. Okay. But Ethereum is the native currency. Okay. इसलिए we don't have to think उतना ज़्यादा. We'll just write address this dot balance. Okay. So this is something that you have to learn. Dot balance, dot sender, this message function. There are also other variables here, like message dot some other thing that you can use in your contract. So for this, moving on. So let's talk about this. हाँ ये उल्टा होगा, मुझे लग ही रहा था. ठीक है. This is the main function that we'll be working on. We're creating another function, which is trying to tell what is the price of the output reserve with respect to the input reserve. So P x equal to y upon x, P y is equal to x upon y. So again, moving into this, let's just think about it. P ETH equal to 2 of TKN and P TKN equal to 2 of ETH. Does this make sense logically? I'm basically saying that 1 ETH is worth half a token and 1 token is worth 2 ETHs because there are twice as many ETH as there are tokens. Simple demand supply thing. Okay. इसी को we are implementing here. As simple as that. Make sense? We'll modify it later, but this is the formula that we're implementing. Now, the one thing that you can question is why is the token value only determined by the ratios of the reserve quantities? You can also say that maybe let's say I go to some centralized exchange जहाँ पे Ethereum का trading होता है. Then I ask them what is the price of Ethereum with respect to some token. Let's say that you are not even launching a new token. You have Dogecoin and you're trying to create a swap for that. Okay. So how will you? So clearly there is a market price value for Dogecoin with respect to Ethereum, right? Market price. So why don't you go and ask that exchange कि तुम बता दो. कर सकते हो, that's a way of doing it, but cool नहीं होगा वो. Okay. So we want to create it algorithmically. That is why we will say that we'll use the reserve pointers to determine the price. Okay. Complications will come. We'll look into that. The only requirement for this is, again, there's some requirement, but the reserve should be greater than 0. Okay. So things like this may be obvious to us, but for the contract, it is negative. Agar galti se it gets negative reserves, then it will not be good for us. Okay. So then we simply say, and this is sort of the error message that we send if the first condition fails, right? It's a function call. Okay. ज़्यादा इसमें time spend कर दिया. The problem is this. Okay. Now try to understand the problem. Yeah, this is one of the first ones. So we deposited 2000 tokens. Okay, यहाँ तो उल्टा हो गया है. So I just do this. ठीक है. 2000 tokens, 1000 each. Obviously, ETH is more valuable. So we have one ETH is worth 2 tokens and one token is worth 5. Okay. Simple. The problem is, let's say what happens if somebody tries to swap 2000 tokens of if we swap 2000 tokens of 2000 tokens for it. Okay. Basically, what will happen is we are trying to buy all the Ethereum in the contract, which is possible. Okay. तुम बस उतना tokens दे दो and then you swap in the entire reserve of Ethereum. Can do, possible. And the problem is we do not want it for our exchange, right? Because our exchange is supposed to have liquidity at all points. What happens if some other person comes and says, "Okay, अच्छा मुझे tokens देंगे, मुझे ETH चाहिए. I want to swap." There is no ETH in the reserve, so it cannot give anybody. Get the problem? So this happens because the price curve, मतलब the reserve is this is the. Can you tell me what this curve is? From the last, I think we discussed like there were like a bunch of accessibility shapes there. I will describe it different. So this is the bonding curve. It's called a bonding curve, and it's a constant sum, which is basically x plus y equal to k. It touches the x and y axis, which means that at some price level, some reserve quantity level, the other token will drain out, which we do not want. So what we want is ideally, just think about in terms of mathematically, what sort of function do you think you want? Jahan pe it never touches the axis. Asymptotic curve chahiye, so like a hyperbola or something. And that is exactly what we'll do next. So we remember this guy, right? So we'll basically say that let's say we increase that by some directs. Okay, so we are giving token x ka kuch quantity. We are taking out token y ka kuch quantity. So of that equation you get this. Okay. This is again basically saying कि this is बता सकते हो ये क्या है? What is this value? मतलब in terms of the tokens. This is our ये हमारा वो था ना pricing function था, right? Where we had input reserve by output reserve. मेरे को board work अच्छा करना पड़ेगा. ठीक है, basically we are saying कि ETH is equal to this by this by this. We are modifying that ratio to say not that but this. Okay, where we are taking into consideration of two new variables, which are the current reserve of both the tokens in the contract and the nudge amount, which is del x. Okay, उससे हमें पता चलेगा nudge amount in y. Nudging is this change delta, right? This tells us कि let's say assume कर लेते हैं कि x is ETH. So this will tell us for del x amount of ETH, how much of the token you will get. ठीक है? Make sense? बाकी का is okay, I guess. हाँ, it's pure and private. ठीक है? Private क्यों है बता सकता है कोई? Simple. अरे यार इसको बंद करो. System off नहीं करना. ठीक है ना? Simple logic है. Security measure है. Because this is a critical function, we do not want other people to use it. This is something you'll have to think about when you write your contracts. Okay? You make sure that only the interface, only the part of the contract that should be exposed to the outside world should be exposed. बाकी सारे private होने चाहिए. And there are other levels of access. Okay? Okay, this is the curve and it aligns with laws of demand and supply. One increases, the other decreases, and relatively the price is set. So इसमें अच्छी बात ये है कि let's say, I mean, if you sort of plot this in Desmos and actually try to look at the values, what happens is, let's say somebody as a reserve में state था, ठीक है, and somebody actually comes with 2000 tokens, ठीक है, and tells you कि okay, I want to buy, ठीक है, he will not get 1000 ETH. He will get something less than that. That is verified with the formula. When you, I mean, you can go to infinite amount of X, you still never reach the reserve quantity. So that is one thing. So basically what it does is we're mathematically ensuring that at every point there is some amount of both the tokens in the account. Okay. Cool. And you can say how it happens. So I think we have talked about this. The price is dynamically set for each unit of token brought. Okay. Like once you buy 1 unit of token, उसके बाद the token becomes more valuable. So उसका price बढ़ जाता है. So the next token is more expensive than the first token. And that is manifested in this formula. Okay. So we have used two things. We'll move forward. How much time we have left? Damn. जल्दी निकल गया time. ठीक है. मनोज कहाँ है? कितने टाइम लगेगा तुझे? ठीक है. So you probably have to cut my part for my short. I'll go through थोड़ा faster. ठीक है. So we have written how many functions abhi tak? We have written add liquidity, which is just providing liquidity. Liquidity matlab that is a special function क्योंकि उसमें you are not expecting anything in return. ठीक है? You are just saying कि मेरे पास ETH है, मेरे पास token है, दोनों डालना. ठीक है? A normal user will have either one of the token and want to swap it for another. That is like add liquidity is a different function. Then we have get amount, okay? Get reserve, and then we have get price. Okay? Get amount is like the क्या था get amount? नहीं ठीक है, मतलब वही get price है, get reserve, add liquidity. ठीक है, get amount बाद में आएगा. Cool. Moving on to swapping functions. This is the crux function. It will use all the functions that we have written above to actually facilitate a swap. Okay? This will swap each for token. Okay? Let's try to understand what is happening here. Function this, it will take min token. We'll talk about what min tokens is. Public payable, it's payable because you will be submitting each to this function. Okay? Get reserve, token reserve, which is current supply of token in the contract. We'll use this for determining what? The price. Well, the quantity of tokens to actually give back to the user. Okay? Which is calculated very conveniently in the function get amount. जो हमने अभी देखा that del y is equal to y del x by x plus del x. Okay? So this is what the tokens bought variable stores. And what does it need? It needs going back to the function. It needs three things. Input amount, which is the input amount of what? The Ethereum. Okay. Input reserve. Input reserve यहाँ पे क्या होगा? Since it's X, so input reserve will be the reserve of Ethereum. Okay. So this is like Ethereum and the output reserve, which is the reserve of the token. समझ रहे हो क्या हो रहा है यहाँ पे? ठीक है. All मतलब faces are looking through confused, so बता देना. And then what we do is, I mean, same thing we are doing here. First, we have the input reserve. So we have talked about message as the special object storing information about the transaction. This transaction comes from the user. This particular message, there are variables. One variable we saw was sender, which is the address of the user creating the transaction, who address it. One other thing is, if you create a transaction with some value in your MetaMask wallet, no value will be stored here. So that is what the amount the user is willing to pay. So that is the first amount, which is correct because our function signature में the first value was the input reserve, input amount, right? Then the second amount is the input reserve, which is calculated by this one. Okay, as we have talked about this. So we have the simple address based on balance. Now, why am I reducing the messenger value? This is the Ethereum thing. By design, what happens is, as you create the transaction, the balance is updated by the transaction of value. So let's say if your contract had 10 ETH, अभी तुमने अगर एक ETH का transaction instantiate किया, तो by the time the code reaches that line, it will actually show 11. But what we want is the original supply of token. मतलब original supply of ETH in the contract. So we have to reduce minus 1. ठीक है, तो हमें 10 चाहिए. Because हमारा formula में we need to have the supply of token. मतलब supply of token and supply of ETH. समझ रहे हो? ठीक है, why we show 11? What happens is, तुम्हारे पास मान लो 2 रिजर्व है तुम्हारे कॉन्ट्रैक्ट में, टोकन का, ईथ का, ठीक है, ईथ का वैल्यू तुम्हारे पास 10 ईथ, ठीक है, यू क्रिएट अ ट्रांजैक्शन 1 ईथ का, ठीक है. नाउ व्हाट हैपेंस इज बाय डिजाइन इथेरियम विल ऐड दैट टू द कॉन्ट्रैक्ट फॉर वैल्यू. इट विल बिकम 11 बिफोर इट स्टार्ट्स एग्जीक्यूटिंग दिस फंक्शन. व्हाई इट हैपेंस, वो इथेरियम का डिजाइन चॉइस, ठीक है. Now that is why for but you need to know about that when you create your, whenever you write a function. इसलिए यहाँ पे you reduce it. So because in the formula we need the initial reserve of both the tokens before the transaction, before the swap happens. Swap के बाद दोनों reserve values change हो जाएंगे, like because the amount of tokens in the contract will change. उसके basis पे price भी change हो जाएगा, ठीक है. And finally we have the token reserve which is given by the function get reserve, ठीक है. Cool. Token drop मिल गया. Now this line basically says कि कुछ एक minimum token value है, ठीक है. उससे अगर ज्यादा होगा तभी हम अलाउ करेंगे आपको, उससे कम हुआ तो नहीं अलाउ करेंगे. ये क्यों करते हैं, इसका भी बहुत सारे रीजन है. What happens is arbitrage हो सकता है. Arbitrage पता है क्या होता है? ठीक है, these are financial terms. What happens is basically अगर since Ethereum में you can have arbitrarily small amount of, arbitrarily नहीं, मैं 10 to the power 18 तक जा सकते हैं solution. What happens is कि अगर तुम बहुत कम amount of ETH के साथ swap करना चाहो, it is possible by default. The formula will give you tokens उसके लिए भी, but उससे there are unintended effects such as the opportunity for the price to be manipulated by some bot, etc. So उसको prevent करने के लिए we say that some minimum token amount is there. उससे ज़्यादा
कब तक है?
830 million.
अच्छा, आप इसको सिर्फ नीचे गिरा.
हाँ ठीक है.
ठीक है, जा सकते हैं.
Okay भैया, thank you. ठीक है. So we want कि ये token amount is just a safety net कि हमने एक minimum amount of token चाहिए, उससे कम हुआ तो हम sort of उस transaction को हटा देंगे, ठीक है. How do you set min tokens? No idea. How do you decide what should be the minimum amount of tokens bought in your reserve? Design choice है, ये तुमको थोड़ा सा market research करना पड़ेगा. It comes from that, ठीक है, not necessary. In fact, min tokens can actually be dynamically set by the provider. मतलब MetaMask या फिर even the user can set. ठीक है. Why they will set is again something called slippage. इसके बारे में भी last lecture में थोड़ा सा बताया ना, ठीक है. Which is like जब तक तुम्हारा transaction run कर रहा है, somebody else might also create a transaction, and उसके transaction की वजह से the prices might slip, which means your order quantity, the amount of tokens that you expect to buy may change. तो उस चीज के against protect करने के लिए you will want to set your own minimum tokens. मुझे इतना minimum चाहिए, अगर इतना मुझे नहीं मिलता है तो I will not let the transaction happen. Doesn't make sense. ठीक है. I mean, I can give you values, but time कम हो रहा है. And then basically then there is this another, we call the contract. We say कि transfer कर दो इस बंदे को इतना amount. ठीक है. You guys want to know how ERC20 actually implements this token transfer thing? ये कुछ नहीं है, basically एक mapping है. It's like a account book, a ledger book in its own right. Basically एक address से uint 256 का mapping है. ठीक है, मतलब let's say there are 5 people who are using this contract, ठीक है, and there can be any number of people. So let's say OX1, OX2, OX3, blah blah blah. And what the token does is it basically creates a ledger. इसके पास 256 है, इसके पास 0 है, इसके पास 10 है, and ठीक है, and obviously it will have like this particular token. So let's say this is the contract itself. भाई क्या हो रहा है? Let's say this is the contract itself, ठीक है. and let's say this is some person who created the transaction. So इस particular statement के बाद what happens is यहाँ से 256 कम होकर के they will just change the value. They will write 255 here and they will write 1 here. That is what this swap is. ठीक है, but ये हमें करने की जरूरत नहीं है. This is what the contract ERC20 thankfully does for us. So this is the first function that we write. Pretty much similar in vein. We have to create the other swap. So if somebody has token, they want to buy back ETH. Okay. Let's try to understand this एक बार. We provide a token so we can interest. ठीक है. Important thing यहाँ पे is the token is not fundamental to the solidity. Okay? So in the previous function, we had message.value to tell us हम कितने का order place कर रहे हैं, right? Message.value. But यहाँ पे we have to pass that value as a parameter, which is what token sold is. है ना? वैसे ही मेरे पास इतना token है, मैं selling it, and the minimum is like इतना minimum मुझे चाहिए, ठीक है? Same thing happening in reverse order. Reserve चाहिए मुझे, Ethereum what is get amount. This time we change the positions of Ethereum and tokens for each other. So in that common action by उल्टा हो जाता है, and you get the amount of each that we want. ठीक है? You can work this out on your own. Just look at the function signature, okay, of get amount, and उसके basis पे try to figure out why this makes sense. Again, a required statement, and then you have these two things. यहाँ पे दो चीज होता है, ठीक है? First, you need to transfer tokens from the sender to your contract, right? Because you are swapping for tokens, right? So there's two things happening. First, you take that token into your contract, and then you give back ETH to that contract, which is happening in those ways. So first, you make the interface transfer from the sender to my address, this amount, okay? And then payable is a special function, which is basically paying this person this amount. Okay. So the thing is, we have completed first part of my part. Okay. So this is this has been Uni Swap को बिल्कुल पहला version. This was made public in 2018, I guess. है ना मनोज?
Yeah.
Uni Swap was 2018. You have seen the guy is currently worth $300 million just to write this thing. Okay. The fundamental idea was you can eliminate the second person creating a trade, okay, which was actually very, if you think about it, if you try to study thoda sa history of finance, it was a very revolutionary. Okay. So just the thinking is what matters, and the contract to put a walkthrough karwa diya. The writing is very simple. Now, थोड़ा complicate करते हैं. It is obviously not that simple. मैंने बहुत simple बताया. It's a toy Uni Swap, obviously. If you go and read the actual Uni Swap, it's more secure and more required sequences. But yeah, we'll just touch upon one important concept. Okay. Problem with liquidity. एक मिनट रुक जाओ. ठीक है. So think about this. एक scenario है. यहाँ पे तुम्हारा अपना token, ठीक है? And you want to create a market. So starting with you will just make your token as in out of thin air. You will add liquidity वाला function को call करोगे. You will have some ETH. दोनों को you transfer to the token to the contract using the add liquidity function. जो हमने starting में देखा. That function is special because उसमें दोनों चीज एक साथ आता है. ठीक है? Now the thing is, why should anybody want to provide liquidity? Yeah. Fine. Just I'll touch upon this. मैं ज़्यादा code नहीं देखा. Provide the slides, you can go to the code and also provide links. Okay. So the thing is, why should anybody provide liquidity for you? Because providing liquidity means they have to lock their Ethereum and token into the contract. You are basically just to provide कर दो. तुम्हारा तो contract में बहुत प्यार से लिखा था, तुम दे दोगे अपने Ethereum, but why should somebody else provide Ethereum? Because originally we had come to the agreement that other people will provide liquidity for everybody. So there's like some group of people who have both tokens. They put it in the contract and they'll say, okay, बाकी लोगों के लिए देगा होगा. Cool. The thing is, you get rewards. You have to put incentive for people. Okay? And that incentive is what the second part was all about. It is something called liquidity pool tokens. Okay, which is a nice idea. We're basically saying that we'll create a sort of pseudo token, okay, for the contract itself that will never be exchanged in the real world. Okay. मतलब वो token सिर्फ मेरे अंदर contract में रहेगा. It will never be used outside the outside the contract. The people will only see token and ETH swaps. Okay. But the liquidity provider token, LP tokens बोलते हैं, it will be my way of keeping track of people who are providing liquidity and kitne proportion of providing. So let's say somebody is providing 50% of the entire liquidity pool. So whatever, yeah. Okay. Okay, let's slow it down. So let's say we have lost my train of thought, 1 minute. So let's say we have some amount of liquidity है, 50% कोई बंदा provide कर रहा है, तो उसको logical बात है कि you should provide 50% of the fees. So obviously somebody is providing reward. Okay, you need to collect fees. So this is what happens because if some user is using your service, using your Uni Swap to create a swap, you will say that you have to provide some fees, which is a logical business. Somebody is giving you something, a service, and you ask for a fee. And that fee is redistributed among the liquidity providers via a formula, which basically says that the higher the amount of liquidity they provide, the more share of the liquidity, the share of the fees they will get. Okay? Basic cheese. How it is implemented? I wanted to go into this, but okay. I'll not skip through this. This is the LP token idea. So formula dekh lo ek baar, basically simple formula. Okay. In fact, what the skeleton code, the first one that we have written, but usme thoda sa changes karne padte. Okay. You basically say that this amount minted is what? This is the mint. This minting. Minting is a creation. This out of the blue you create. This creation is of the LP token. Okay. The LP token is a quantity. This is total amount into ETH deposited by ETH. So somebody is providing kitna amount of ETH, he will reserve है. उस ratio में what's total amount? Total amount of what? Total amount of this will be total amount of the LP token. Okay. Basically, to make fraction of that, you are allocating to this person. Get my point? Okay. You can read through. It's basic math, just fractions and everything using there. Okay. Let it go. Skip through this. Removing. Again, removing liquidity is the same thing. What you're doing is you are. This is actually very cool something. Think about this. You are using the LP token for a particular user, again, to determine how much ETH and token they should get back when they come back to you after, let's say, 10 days. So बंदा पहले दिन आया, बोलते हैं कि मेरे पास 10 टोकन 10 दे दो, ठीक? After 10 days they come back and they demand their ETH and token back with the added rewards because in the provide connectivity. So how do you calculate the rewards? The reward is calculated by the function of that same reserve by depending on the swing kitna hoga. I think the amount is that the amount of LP tokens at this guidance. Okay. Not going into details when I mean I'm not even trying to decipher this function because इससे पहले मुझे और पहले वाले function को describe करना पड़ेगा. So just skipping through this. I'm not skipping. I think this is pretty much my part. Factory was, if you remember from some time back, we have actually talked about 3 things, right? The project was of 3 things. There was a token, there was the exchange for Ethereum and some token. So for any contract, it can be a pair contract, right? Ethereum को किसी और के साथ swap कर सकते हो. That is one thing. But let's say you have some other token 2. उसके you have to make another contract with Ethereum. Okay? So that is how you go. Factory is supposed to keep track of all such contracts that have a swap with ETH. Again, it is what this is what it is doing. Address of the token to the address of the exchange. Okay. So the factory is storing two things. It is storing the let's say मान लो कि मैंने इस यूनिट को बनाना, ठीक है. I also create something like क्या नाम दे दो, some other contract which also has its own ERC20. समझ रहे हो? This is some other exchange, exchange 2, exchange 1. So I need to create इन दोनों का address in my factory. ठीक है. Factory is like just creating exchanges. Bunch of stuff happening. Okay, you need to ensure that the exchange has not already been created for that token. Okay, all that is provided in the, that is what the exchange already exists statement is. Okay, just look up hota hai. Skip. Token to token swap is again very cool. It's basically saying I'm just putting possibilities now. You have ETH to token 1, you have ETH to token 2. Okay. What if somebody comes with token 1 and wants token 3? So one way to do is to create two transactions. Each se pehle token one se likha फिर each se wala. Otherwise, you can just give them this token to token is a cool thing where you try to attempt. You basically look at your factory. Okay. You look at your factory. That is like a directory of all the tokens that you have. You see if the token that the person wants is there or not. If it is there, you try to attempt a double swap. First you get ETH and then you use ETH to swap for the second token, and then you give it back to the person. This is a token to token swap. Take care. Just that was the final part for my end. Now spelling another. Now I think Manoj will come and he will take. Thank you very much. और किसी को कुछ डाउट है इस पे तो पूछ लेना. I mean critical बहुत also. ठीक है. But yeah, that was it. Now we can talk about good stuff. Other way.
Let's get into a lot of interesting stuff, okay? So let's discuss what are the current happenings in Web3. What are the things you guys heard till now? What did you hear except Ethereum, Bitcoin, Ethereum, virtual machine, Solidity, smart contracts? उसके अलावा क्या सुना तुम लोग अभी तक? Dogecoin? No. अभी तक कितने लोग? How many of you guys made your first transaction on any testnet? Transaction तो पता है ना? Okay. So make a transaction at least and feel how it happens, and try programming transactions in a programming language instead of using Remix. Okay, that makes you a better blockchain developer. So let's get into the topic. Before diving into what's happening in Web3, let's know what Solana is. Solana का नाम तो सुना है ना last lectures में. I'll give a simple analogy between Solana and Ethereum so you guys will understand, and also I'll include traditional computers वाला thing. कितने लोगों को पता है तेरा computers में cores है? 8 core CPU, 4 core CPU, 2 core CPU. You guys know it, right? So what does that mean? You can execute computations parallelly using those cores, right? If we consider that part, Ethereum has only a single core. So you can execute one transaction at a time, right? So as you're not having any additional cores, you can't execute multiple transactions on Ethereum. So there comes Solana. What Solana does is, it is a multi-threaded blockchain. You can execute multiple transactions at the same time. And we can say whenever a transaction is executed, state of the blockchain changes, right? So why can't, so why and how Solana is doing that? Okay. Let's say we are having a very big blockchain and blockchain uses Merkle tree. I hope you guys know what Merkle tree is, at least what a tree is. Tree has leaves, branches, right? How many of you deny with that? So let's say this to be a Merkle tree. And let's say there is some transaction. So a transaction may touch this part of the Merkle tree, right? I mean Merkle tree in the sense, मान लो tree है, tree का branches ये है, tree का leaves ये है, okay? Getting? So let's say a transaction touches only a part of Merkle tree. So rest of the Merkle tree is not getting touched, right? So what Solana does is whatever transactions will have non-merging branches of Merkle tree, they will get executed parallelly. Okay, that's how Solana achieves that thing. And why is Solana, how Solana can do it? In Ethereum, we had storage slots hoga, memory slots hoga, right? And contract address hoga, storage address hoga. And so in a contract address, you will have storage addresses. But in Solana, it is something different. In Solana, we'll have address for everything. We'll have address for contracts. We'll have an address just as a contract address, even for storage. So everything will be just as a leaf in a node, leaf in a Merkle tree, okay? So using that property, Solana executes multi-threaded transactions. So that's about Solana. So few questions for you guys. I asked the last one. So what do you find attractive in Web3? Yeah, of course. Other than that, cringe posts. I mean, the posts which are very weirdly sounding, but has a lot of information in them. Or else news channels pushing about Bitcoin in their programs. What's more interesting to you? I mean, give any sort of answer. उसके अलावा nothing. Community. Okay. Twitter. Okay, let's leave it. I mean, what do you guys hate the most? At least the guys who have made any transactions on blockchain can answer. Okay. How many of you read the last conversation which we had in the group last night? Transacting, MetaMask popping up, accepting transactions and doing all this shit. At least I hate that. If not you guys, okay? I don't want to do those type of things. I don't want to remember my seed phrase, my mnemonic. Because if I create a multiple accounts, where should I write it? I don't trust anyone. And I can't remember that. So I don't want it at all. So what is the most favorite feature you have? भाई अब तो कुछ बता दो. Decentralization, transaction, complex things, something. Or else I told everything. Okay. MetaMask bata do at least. Remix, used it right. Solidity, NFT, NFTs. You guys? Straight to the point. So what are the current happenings in Web3? I'll tell about all these things in a brief, but we included reading materials extensively for this, which will help you to start on it at any moment. Okay. So current happenings in Web3 is account abstraction, zero knowledge, scalability with layer 2s, modular blockchains, REX, smart contract security, BitVM, Bitcoin halving, and interoperability. New terms. So let's get into them. So first we'll discuss about account abstraction. The thing I hate the most, what I told you, popping up and signing transactions on MetaMask, etc., right? And also if I want to transact on multiple blockchains, if I have accounts on multiple blockchains, I need to possess their native gas token, right? So I hate that. So account abstraction exactly solves that problem. No need for you to remember any seed phrase. No need for you to sign any transaction. You can easily integrate your Web3 user you can easily improve your Web3 user experience. I mean, let's say if you want to play a chess game, I mean, I'll tell something about it later. If you want to play a chess game, if you want to, and it is deployed on blockchain, whenever you want to make a move, you made a move, okay? And it always asks you, sign transaction, send transaction. How would you feel, right? Irritating, you want to break your phone at least. If not, you want to throw something else. If it is at a last 10 seconds moment. and the transaction also takes some time to complete, right? So we don't want such things. We want account abstraction in a way that it automatically handles that thing in a secure way. And if I want to, there came a new blockchain. I thought blockchain Celestia launched today, and I want to buy some or interact with some contract on Celestia. Celestia has some different token. Uska liquidity बहुत खराब है. So how can I get it? It's a little problematic. So using account abstraction, even if you don't have Celestia tokens, someone else will pay gas fees for your transaction, and you somehow compensate the person who made your transaction on your behalf. Okay, that person is called as paymaster. And I think this is a good introduction to you on account abstraction. At least convinced? Okay. So zero knowledge. How many of you know both of these terms individually? Everyone, right? And how does those both combined sounds? Zero knowledge in the sense we don't know anything. But it is completely opposite. Zero knowledge is something different phenomenon. It uses linear and abstract algebra. You guys will learn about linear algebra in your MTL 101 course. I recommend you guys to at least do it well, not MTL 100. That course will be a really interesting one. If you get your hands on with linear algebra, then you can later on do many different stuff using linear algebra in zero knowledge field. Actually, whatever we do on blockchain is something public. Let's say I know some secret. I mean, I told this example while on tour of stalls. Again, I'll tell it. Let's say I have a vault and somehow I got Kohinoor from Brits. Okay, that's some different story. I don't want to discuss it now. And I have Kohinoor in my vault, and I am the only person who knows passkey for that Kohinoor's vault. Okay, I want money now immediately. So what I need to do, I need to sell that vault to someone for some price. But whoever are there, they won't trust me. Why should they trust? So I need to prove them that I have Kohinoor in my vault. And while proving, I shouldn't compromise the vault. I shouldn't even compromise the passkey for that vault. Okay. So using zero knowledge, we can do such type of things. Getting? You will prove some other person that you know the password for that vault and the vault is having Kohinoor in it. So if that person is convinced enough, what happens later? He'll give you money and you will give him the password and the transaction is complete. So understood how zero knowledge works? Clear? Any doubts on? Okay, let's move on to the next part. Also, there are few books called Moon Math and Rare Skills, and there is a YouTube channel called Zero Knowledge. All the links are attached. If you guys are interested, refer them in reading materials. Okay. The most interesting part. Scaling with layer 2s and modular blockchains. हम तो अभी तक सुना blockchain ट्रायल में है. Blockchains के लिए layer 1 को scale करने के लिए layer 2s है, right? And layer 2s में बहुत layer 2s अभी आ रहा. Zero knowledge layer 2s आ रहा. Optimistic layer 2s आ रहा. And that part we all are aware of, okay? But what are modular blockchains? Module तो पता है, I guess. No. Module मतलब textbook modules तो होता है ना. Think something in the same lines. Okay, I'll tell what modular blockchains means. Okay, so now what we'll say. Ethereum ka feature what I like the most is security, what Ethereum gives to us. Okay, and what I like the most in Solana is multi-threading in Solana. Okay, so I want to mix such interesting parts. And what I like the most in Celestia is a blockchain. What I like the most in Celestia is data availability by Celestia. We know we have till now, you guys have heard there are multiple layers when a blockchain functions with, like execution layer, consensus layer, and data availability layer and settlement layer, right? Execution layer is where your transactions get executed. Consensus layer is where all the nodes agree upon your transactions. Settlement layer is where we settle all the disputes. And data availability layer is where we obtain the state data whenever it is requested by any node, and we store the data. So if I want to store data of a node on Ethereum, it costs me so high. So there came Celestia and some other type of data availability layers, which help me to store and retrieve data on blockchains. So now I want to make a modular blockchain. What happens is, so I want to make a blockchain for some purpose. Let's say I want to make a gaming blockchain. I want security, I want speed, I want fast data availability. I can't choose Ethereum, वो slow है. I can't choose Solana, उसका security कम है. I can't choose Celestia because उसका security कम है and उसका speed का scene तो अलग है, right? So what I'll do, I'll take execution layer from Ethereum. I mean, execution layer from Solana, security in the sense settlement and consensus from Ethereum, and data availability from Celestia. I'll mix all of them. I'll cook my own blockchain, and my blockchain will function better, right? So it's like whatever best ingredients we are having, we are utilizing the best ingredients to make at least not the worst dish we are having in the market. I won't say the best dish, but not the worst dish. So if you guys are interested on these type of things, resources are attached again. You can refer it. So now let's do something different. So we guys know zero knowledge. We guys know EVM. So what is zero knowledge EVM? Maybe whatever you're thinking, you can put it out. Of course. Partially. Any one of you? Mix kar do, whatever comes to your mind, put it out. Zero knowledge का definition और EVM का definition mix करके at least someone बता दो. Okay. What it is in the sense, zero knowledge EVMs, what they do, they make computations and they prove computations on chain on using EVM as the execution layer. And it's like most of the layer 2s use ZK EVM and they store and execute transactions, prove their transactions to Ethereum using instruction set of Ethereum. OP code का नाम से एक चीज होता है Ethereum में. It is like instruction line for assembly. Assembly language जिन लोगों को पता है, they'll understand. Assembly code is analogous to OP code on Ethereum EVM. Okay, so let's see few things like Polygon is doing some ZK EVM. Starknet is doing some sort of ZK EVM and Miden is doing some sort of ZK EVM. I'll tell one of the best feature what I saw till date. अभी तक transactions कैसे execute किया हम लोग? How did transactions happen till now? So transactions कैसे होगा? User 1 है, user 2 है, and user 1 transacts to user 2. Simple, right? Somehow, if not user 2 may be a smart contract or user 2 may be a person. Transactions got executed in this way. Nothing else is included. I mean, in between we have JSON RPC providers, we'll send it to blockchain, mempool se bahar aayega or transaction execute hoga. But in short, this is how a transaction in theory gets executed on any blockchain till then, right? So this is changed now with the introduction of Miden VM. Miden VM is a zero knowledge VM, and what it does is, instead of this part, we'll send a note, and this note will get done. And user 1 is there. User 1 issues a note that if someone gives me 1 ETH, send 500 DAI to that person. And that note issuance will be done in transaction 1. And someone who has seen this transaction, what they'll do, they'll claim this note by providing 1 ETH. Okay. And they'll get 500 DAI to them. And that happens in transaction 2. And in between, there came nodes. Nodes like we'll just make a checklist of these things should happen if these things are there. So even an individual transaction will work as a node, and the person can anytime withdraw their nodes after the transaction being completed. So what is the benefit of this? The nodes store the data on blockchain. We can store the data in any of our computer, and we can prove that this computation is valid. That's it. And how we'll prove this computation is valid? Using zero knowledge proofs. That's how Miden VM works. Okay. In simple, this is how Miden VM works. But in execution, it is a little bit complex, but we are not going into that part now. So I think your favorite part is here, Basil. The best part. Security, DeFi. Okay. It's all about smart contract auditing. And why it is the most favorite part of many people. It's like capture the flags. It's like some people will write code on the blockchain. And before deploying the transactions, they want to verify if no one can break the blockchain. We'll continuously hear about bugs, don't we? Bugs in a software, bugs on a website. So if there is a bug on a if there is a bug on a smart contract, can we fix it? No, right? So before anything wrong happens after deployment, there comes smart contract security and auditing of smart contracts. And this is one of the most happening things because many of the protocols are transferring or thinking to make their Web3 versions, right? And this is one of the most prosperous field. I mean, for next 1 year at least. So I think we are nearing the end, and let's discuss two of these things, which is cross-chain interoperability. Interoperability, cross-chain. Do you guys know what they both mean? We heard oracles, right? We heard many layer 2s are there, right? And we want, what if instead of transferring data to any real-time API, how can we transfer data to a different blockchain? The answer is cross-chain interoperability. It's simple. Instead of real-time data transfer between blockchain and external world, if you want to transfer data between two blockchains, then it is cross-chain interoperability. Getting what I'm saying or any doubts? So there are few protocols like Chainlink, CCIP, Wormhole, which are highly involved in cross-chain interoperability. What they do, they have their own mechanisms where they execute cross-chain transactions in a decentralized fashion using their Oracle networks. Okay. And so we know what is the difference between Bitcoin and Ethereum. Ethereum में तो we can use it as a general purpose computer. वो तो पता है ना? भूल गया. हाँ. Bitcoin में we can't do it. We just only send Bitcoins, right? So अभी these guys, developers of, I mean, some of the active members of Bitcoin community have bought something called BitVM. And what BitVM means is we can compute anything on Bitcoin. Does that mean Bitcoin is turning to be Ethereum? How many of you agree with that? It can't. Okay, it never, because Bitcoin is very vast. Computation on Bitcoin is too costly. And even if we want to make any sort of computation, it won't be as good as EVM. That's what the white paper of BitVM states. BitVM's purpose is any computable function can be verified on Bitcoin. I mean, if a function can be computed, it can be verified on Bitcoin, but you won't get any functionality of smart contracts. Okay. And it's if we want to go into something technical, it's like a Turing complete machine. You guys may have heard about Turing complete languages, Turing complete machines, right? And also other thing mentioned in BitVM white paper is BitVM is not as good as EVM, but BitVM is slower, more expensive, and more complex. So I think this answers you my previous question. So if you want, I'll send the thread of BitVM and the white paper of BitVM. And what next you guys can do. If you guys got a good understanding on the theoretical concepts, and if you guys, if in case comes out of Remix environment, write smart contracts in your local environment, publish the smart contracts. Okay, you guys can do a lot of things. Remix is just a big beginning one. If any guy comes in, we just can't ask him to set up all the environment and make that first transaction. It would be too hectic. So Remix is introduced because to make any beginner to transact in minutes. But it is not actually the infrastructure tool which we need to utilize. So what we guys suggest is start writing smart contracts, familiarize yourself with JavaScript or Rust, use local development environments like Hardhat, Foundry, Ganache. Do your own research first. Here you won't find resources very easily. You need to search online a lot. So you guys need to get better at surfing online. You guys need to get better at using AI tools in generally to a certain extent. Okay. Till now, if you guys ever read any documentations, you'll see this documentation is based on some sort of white paper, which is written by someone on some date. So white papers are the best thing which you can read if you want to understand in depth what's happening on a protocol in a short period of time. Okay. White paper is something similar to as research papers, but research papers, some other forms of, some higher level forms of white papers. And if you guys want to become a really good developer, in any case, read and analyze code which is written by other developers. Okay, it will help you to understand what are the best programming patterns other developers are following and what you can do best while you are programming your code. Okay, and be active on Twitter. The must. Okay, be active on Twitter. Follow OGs on Twitter, and also join few communities which you feel worthy on Discord. If you need any help, you can shout out for help at relevant places. Okay, at relevant places. And what projects are we guys doing currently? Block Sock. Some of our seniors are working on DeFi and perpetuals, and some of us are working on account abstraction and infrastructure, multi-chain liquidity. Multi-chain liquidity in the sense I told, if you want to transact between if you want to send data between blockchains, that is interoperability. If we want to transfer assets between different blockchain, that is multi-chain liquidity. Simple. And on-chain chess game, my most favorite one. And that's what we guys are doing. I think this is the last lecture of this cohort. And I think this is the conclusion. Resources are made available to you, and I'll share those resources in a while. And now I think we also mentioned that we'll have a discussion regarding ETH India. So whoever are interested or want to register for ETH India can stay now. Okay. And we are done for this. Anything you want to add, guys?